that will miss this class anyway. If you go on Agile Mind, you're gonna see units. We're gonna go to, you go to my courses, and then you go to unit 18, polygon and special quadrilaterals, the overview. So, as we know, we have many types of polygon. As we've already mentioned, the list of them is triangle. Then we have for quadrilaterals, four-sided figures, we have pentagon, and then the list continues. So these are just some samples of polygon. As you can see here, this is a kind of clothing material or painting material, drawing, where you can see different types of polygon. Here you can see this triangle, some other triangles inside. Where's my touch pen? So all these shapes here, all these individual shapes are polygon. This is a triangle, it's a polygon. And inside it, we have various triangles, you see? All these are polygons. And this is a quadrilateral. I don't know if it's a square or a rectangle. But anyway, inside it, we have triangles, we have hexagons, six-sided figures, These are just visual representation of everything you want to see about. Even we have four-sided again inside. We have three-sided, and everything goes, and it's quite beautiful. And then the next one, it's about different road signs. They are made up of different shapes. As you can see, the stop sign is six-sided, eight-sided rather. So it's an octagon. And the yield sign is in triangular shape. Stop ahead too is, as you can see, the stop ahead. What kind of shape is this stop ahead? What kind of special parallelogram is this? Yes, this is a rhombus. As you can see, your stop ahead symbol is a rhombus. Road walk ahead too is a rhombus. Also a square that is a bit slanted. And the stop sign, it has six sides. And other, like the speed limit, is four-sided, and opposite sides are parallel and congruent, and not all sides are congruent. So the speed limit sign has a rectangular shape. So it goes on like that. The list is endless. And if you see your soccer, the ball, it has a very beautiful, what's it called? Polygons, representation on it. As you can see, we have 1, 2, 3, 4, 5, 6, six-sided. And the other one is how many sided? 1, 2, 3, 4, 5. So all the white ones here are 6 and the black ones are 5. And when you put them together, it has a very beautiful representation here. And as you can see, this one too is a combination of rectangles put together in various ways, to form a beautiful shape as well. And the combination of five rectangles put together also form another shape that's exactly a pentagon, a hexagon, because when you put five triangles together, you have a whole of a hexagon. And this is also the pentagon, the most powerful video in the world. And if you go on page 2, that was just an overview. So we're going to check each of these terms here. So can someone name one side on this shape? We have how many sides? We have 6. Name one. E? No, the side is from one point to another. You have to read 2 letters. 2 letters. Okay, A, B. So you're gonna see we have A, B, B, C, C, D, D, E, E, F, and F, A. And then in terms of vertex, the vertices are singular form of, when it's one, we call it vertex, but when it's many, we call it vertices. So here, as you can see, each of these dots are called vertices, okay? So if I click on it, A is a vertex, B is a vertex, and it goes on like that. B, C, D, E, F. And interior angles are angles that are inside the shape, okay? So one interior angle would definitely be this one when you move from A to B and B to C. So this is an interior angle, and we have 6 of such in this 6-sided figure. So you see one at C, one at D, one at E, one at F, and it goes on like that. Exterior is always outside the shape, outside the shape. And we know that sum of interior and exterior add up to what? 180. The diagonals mostly are when you join 2 vertices together, 2 vertices that are not next to each other, when you join them together. Like in this case now, since A and B are next together, they cannot be called diagonals, okay? You have to jump B to go to another one. So this is a diagonal. This is not diagonal from A. This is another diagonal. They cannot be diagonal between A and B and A and F because those points and those vertices are next to each other, okay? When these vertices are distant from each other, they can form a diagonal, okay? That's why it says any segment joining any 2 non-consecutive vertices is a diagonal. Non-consecutive means they are not next to each other, okay? So if I click on diagonal, you can see A goes to C, D, E, F, and then C goes to E, F, A. So it goes like that. A goes to C, to D, to E, B goes to D to E, C and F, C goes to E and F, D goes to F, and it continues like that. So a polygon has 3 components, 3 major components. It has its own shape itself, like the blue side. So, or when you join all the sides together, it forms the polygon. That is the polygon itself. And the interior of the polygon is also another component of the polygon, and the exterior part is also another component of the polygon, because with that we can find the number of sides the polygon has. With that we can find each of the interior angle, the sum of the interior angles in the polygon, and we can also find the sum of the exterior, which is always 360, or each of the exterior, okay, which is 360 divided by the number of sides. And we have 2 types of polygons. So we have the concave polygon and the convex. The concave one, the convex one is whenever the diagonals are always inside the polygon itself. Like in this case, if I name this point, if I name the vertices A, B, C, D, E, if I trace A to C, this is a diagonal. It's inside the vertex. If I trace this, it's also inside the vertex. This vertex is also inside the polygon. If I trace B to D, it's inside. B to E, it's inside the polygon. And then C to E, it's also inside the polygon. But a concave polygon is whenever at least one of the diagonals is not inside the polygon. Here, if I have the vertices A, B, C, D, E, I can trace A to C, it's inside the polygon itself. A to E, A to D, it's inside. B to E, it's inside the polygon. But if I trace B to D, this particular diagonal is entirely outside this. Is it blue? Blue surface? Anyway, let me call it blue. It's outside this blue surface. So since BD, diagonal BD is outside this polygon, then this polygon is said to be concave. So convex and concave, the difference is that whenever you build all the diagonals and they are always inside the polygon itself, that polygon is said to be convex polygon. But when the one or more of the diagonals are outside the polygon, then it's said to be concave polygon. You're gonna see the diagonals. Each time they're always inside. But here, some are inside and one guy is outside. So that guy outside spoiled its convex nature, okay? So it makes it concave. So here, these are things we've done before. A three-sided polygon is triangle, four-sided quadrilateral, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, and then 12 dodecagon, okay? And a polygon is said to be regular when it's equilateral and equiangular. Equiangular means all the angles are the same, and equilateral means all the sides are equal. And equilateral is from two words, equi, which means equal, and the lateral, which means side. And equiangular comes from two words, equal, which means equal, and the angular, which means angle. I think these are things we've seen before. That's why I said review of agile mind. So here, as you can see, we also have two types of polygon. We have two types of polygon in terms of the diagonals, convex or concave. Convex when all the diagonals are inside, concave when at least one of the diagonals is outside, okay? And we have two types again of polygon in terms of the sides. So if all the sides are the same, we call it a regular polygon. But in the case where all the sides are not the same, we say that polygon is said to be irregular, okay? So as you can see here, all these four guys are irregular because if you take the first shape, this distance here is definitely smaller than this. If you take this shape next to it, this distance here is quite longer than this. So that's what makes those guys irregular. Always make sure to look at one short side and one long side to advance your argument. So here, this side is longer than this, then it's irregular. Here, the left-hand side is shorter than the bottom side, then it's irregular, okay? So a rectangle is an irregular polygon. A square is a regular polygon because all sides are equal. A rhombus is also a regular polygon because all sides are equal. Next page. So these are the differences. As you can see, the regular ones and the irregular, we've already talked about the irregular on page 4. So the regular ones, the first one here is hexagon. All the sides are equal. The square here, all the sides are equal. Pentagon, all the sides are equal. And I don't know how many sides this one has. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this is the decagon. All the sides are equal here. And always the opposite sides are parallel. Opposite sides are congruent, as we all know. And all angles are congruent in a regular polygon. and all the diagonals are always interior. Then the next shape, the next page rather, or this is just to illustrate what is being said there. Like if, you know, there's some buildings, there are some compounds or some environment or some roads, when you just see those interlock. You just see those ties on the road where they put them together. So this is a kind of making use of polygons. So a road that is tied this way has, you know, if you take one side of this, if you take one particular polygon here, this one, 2, 3, 4, 5, 6. So this is hexagon. So putting hexagon together to form your road, you see how beautiful it is. And later we're gonna still do the angle measurement. I usually see this kind of things in people's compounds a lot in London. When you just get there, everything is just beautiful. And there's no cement, it's just to make the land, you know, the floor flat, put sand, level it, and then put them one by one, just be placing them. And just put the first one, and then you put the other ones around it, and then you put around until they form the shape of the compound. Okay, this, the size you just want it to cover. So here, as we all know, the sum of interior angle is always, we have a formula, we use n minus 2 times 180. So here, if we have a triangle, we have one triangle, the sum of the interior angle would definitely be 180. Even though you move it anywhere, it's still the 180. And if you have a four-sided figure, the sum of interior angle in a quadrilateral is always 360, meaning n minus 2, which is 4 minus 2, 2 times 180, 360. And it goes on like that. If you have an 8-sided figure, it's going to be 1080, meaning 6 times 180. And this is what one of the 5 homework will be based on. So here, if you have a 5-sided figure, the sum of interior angle will be 180. And each of the interior going to be sum of interior divided by the number of sides, as we have, we've done it before. So if you have like 5-sided figure, let me move to 5. If it's 5 going to be 5 minus 2, 3 times 180, which is 540. And then since we have 3 triangles inside here, then each of the interior going to be 540 divided by 5, the number of sides. That's why we have this equation below. Sum of angles over number of sides equals to interior angle. This one's supposed to say each interior, okay? So this is the beautiful formula. The sum of the measure of the interior angle of a polygon is always n minus 2 times 180. So if you are given any kind of polygon, be it a billion sides, don't be afraid of the number of sides. Always do the number of sides minus 2 times 180. So if you have a 3-sided polygon, what should be the sum of interior angle? That will be 3 minus 2, which is 1. 1 times 180 is going to be 180. And the measure of each interior going to be this sum of interior divided by the number of sides, meaning this number here divided by the number of sides here. So that will be 60. And if it's 4-sided, it's going to be 4 minus 2 times 180. 4 minus 2 is 2. 2 times 180, that's 360. And then divided by the number of sides, 360 divided by 4, that will be 90. This is going to be 60. And the number goes like that, goes on like that. So here, if we try to open all these, all these hidden things, this is going to be 60. 4 minus 2, 2 times 160, 180, 360, 360 divided by 4, 90. If it's six-sided, 6 minus 2, 4, 4 times 180, 720, 720 divided by 6, 120. So it goes on like that. 8-sided going to be 8 minus 2, 6, 6 times 180, 1080. 1080 divided by 8, 135. So as you can see, as n increases, when the number of side was 3, each interior was 60. When the side became 4, each interior is 90. When the side is 6, each interior is 120. So as n increases, each of the interior angle definitely increases, as you can see. So in our homework then, when they say as n increases, what happened to interior and exterior? Definitely the interior will increase and the exterior will decrease. So when n is 10, the interior becomes, the sum of interior is 1440, and then the exterior, each of the interior is 144. If we have a 20-sided polygon, the interior going to be 18 times 180. Then each of the interior going to be 3240 divided by 20, which gives you 162. And if it's 100, 100 going to be 100 minus 298, 98 times 180, which is 17,460. 17,460 divided by, what's it called? Divided by 100, gonna be decimal number, yeah, 176.4. So we go to the next page. So this is the formula here. So please, how do we think we can use this formula to find each of the interior? Previously, to get exterior, as you can see here, what did we do? Since we know the number of sides, the formula says n minus 2 times 180. Then to get the sum of interior, and each of the interior going to be that sum of interior, the formula divided by the number of side. Okay, so that's why next thing we're going to ask us to find a formula to measure each of the interior. So since we have sum of interior to be n minus 2 times 180, then once you divide this sum of interior by the number of side, you find each interior. So this is a special formula that you shouldn't forget. This is not really needed. Okay, another thing is the interior and the exterior angles. We know that the interior angle is always inside the polygon and the exterior angle is always outside. And then the interior and the exterior always form a linear pair. As you can see, the blue angle here and the red angle here always form a linear pair. So they add up to 180. So sometimes they might give you one interior and they will ask you to find the exterior. Just do 180 minus that number, okay? Or the opposite might happen. They might say, you know, a polygon has 12 degrees as one of its exterior. Find one of the interior. Just do 180 minus 12. So this is how we always find the exterior. Make sure you take one side and you exceed it, that's the exterior. Take one side, exceed it, that's the exterior. Take one side, exceed it. Once you exceed it, it becomes the exterior. So the number of interior is also equals to the number of the exterior. See, if the interior here is, I think 1, 2, 3, 4, 5. This is a 5-sided figure. We have 5 interior, definitely we're gonna have 5 exterior angles, okay? Then here, since this is a 3-sided figure, this is a triangle, the sum of interior is n minus 2 times 180, that's 180. And then each of the interior going to be what? The sum divided by the number of sides. That was 180 divided by 3. So when you do 180 divided by 3, you're going to have 60. At each of these angles, you're going to have 60. Then how do you find the exterior? We said interior and exterior add up to 180. X plus in equals to 180. Since each of the interior is 60, then it means exterior gotta be 120, because 120 plus 60 is 180. So that's why each of the exterior here is 120. Okay. So when you add these two numbers, it adds up to 180 each time. And the sum of the interior angle in a triangle, n minus 2 times 180, n minus 2, n is 3, 3 side, 1, 2, 3. 3 minus 2 is 1, and 1 times n, 180 remains 180. It's a four-sided figure. You're gonna see entirely it's another thing. Four side gonna mean some people without even calculating, they know the sum of interior angle of different polygons. If it's 3, 180. If it's 4, 360. If it's 5, 5, 4, 5, I think 540 or 5 something. Yeah. And if it's 6, they know, because it's something they've been doing over the years. It's like you working at Burger King, how to flip burger, how to the kind of ingredient you put when they say, oh, I need this, it's easy. So here, four side gonna be n minus 2, which is 4 minus 2, 2 times 180, that's 360. 360 divided by the number of sides. So if you divide 360 by the number of sides, it gives you, it was right angle before, I don't know why I made it small. So if each of these interior is 90, so exterior has to be 90. So when you add these two numbers, it add up to. So what do you observe? Interior 3, when n is 3, each interior 60, each exterior 120. When n increases to 4, you see interior became 6, from 60 to 90, exterior from 120 to 90. When n is 5, interior becomes bigger and exterior becomes smaller. As you can see, as n increases, please, you can keep this image in mind, that whenever n increases, each interior increases and each exterior decreases. Okay. And the next, and if the sum of all the angles, the sum of interior and exterior gonna be sum of interior plus sum of exterior will always be 180 times n. If you don't know the number of sides of a particular polygon, the sum of exterior plus sum of interior is always 180 times n. If it's a specific polygon, we know that interior plus exterior is 180. But if you want to take the sum of all interior and the sum of all exterior, since it's a polygon has n side, so you're going to multiply this side by n. Okay, whenever you are dealing with sum of interior and sum of exterior. But if you are dealing with just one interior and one exterior, it add up to 180. But if it's the sum of all the interior angles and all the exterior angle, it's going to be 180 times n. Only when you are dealing with this specific one, interior here, exterior here, they add up to 180. But if you want to do interior, exterior, interior, exterior, interior, exterior, and add all the interiors together, this plus this plus this plus this, exterior plus exterior plus exterior plus exterior plus exterior, then the sum gonna always be 180 times n. My pen is dead. So here, this is a nonagon, 9-sided figure. So the sum of interior gonna be n minus 2 times 180. N minus 2 is 9. 9 minus 2. 7 times 180. And 7 times 180 is 1260. So I'm gonna move this guy down here. And the measure of each interior, we said, is always sum of interior divided by the number of side. So 1260 divided by 9. What is 1260 divided by 9? Class, what is 1260 divided by 9? Can someone help us? 1260 divided by 9. Okay, that's 140. And we said that the sum of the measure of exterior angles remains 360. Please, in your test, when we come back, if they ask you the sum of exterior angle, it remains 360. It doesn't increase, it doesn't decrease, okay? It remains the same number, 360. It remains the same. And then measure of each of the exterior angles will definitely be that big number, 360, divided by the number of sides. Since here we have 9 sides, so you're gonna do 360 divided by 9. That's 40. So we're gonna stop it here. Next time we're gonna continue from special quadrilateral and then view some other things here. So for today, I think that this is the homework on polygon. So if you go on our LMS page, open this link. It's gonna take you down here, and then once you click, you can start the homework. Nobody has already started. 19 students assigned. Please, you can start and make sure you finish. Just 5 questions about everything we just did, okay? Thank you so much. Do have a wonderful day. God bless you all.